those considerations. First, we'll talk about safety. I think it's a new area and a lot of safety things that will have to be taken care of. Of course, when people started gasoline engines, they had concerns, but now you don't hear about safety there. Similarly, electric mobility is a new area, so we have to have special focus on safety. After that, I'll give you some rough idea about various types of hybrids and how hybrids compare to EVs in terms of the architecture. And then we'll talk about the architecture of an electric bus, which is where I show is in trucks and buses, and the various domain carriers. Some last note, same board, the mobility. It continues a few years. Next slide, please. Yeah, so of the considerations for this webinar in today's session. First one, please remember that EVs are going to take a long time to dominate the market. It's not easy. Fuel vehicles will be around for a long time to come, and at least for the next 30 years, there are still going to be a significant number of fossil fuel vehicles that will be sold. So electric vehicle is evolving. It's not yet real. There are still quite a few applications where electric vehicles don't even stand fuel vehicles because of the ability to pick up energy in the form of gasoline. Go. So don't be in a hurry. The whole thing is going to take a long time. And this COVID issue has made matters worse for the electric vehicle because obviously it's no longer attractive to go electric. Next point is this is, remember, it's not predominantly driven by the environment. The electric vehicle comes with its own problems in terms of environmental impact, especially the battery and the disposal of the batteries. And it's not something where people spend conditionally for the sake of environment. So the costs are quite high still. So given this, you have to remember that electric vehicles will take only money sense. Otherwise, it will not take off very much. You will see a lot of vehicles in the papers, but you will not see vehicles on the roads. And if there are no vehicles in the roads, the career opportunities are not going to be that high. The company, they have to make their profits and in turn revenue. So economic growth is important, and we are not there. The other one is, of course, regulation, where the government passes a law saying, you know what, in this city, you can no longer register a new fossil fuel vehicle. So regulation and economic relevance are going to be important. And one of the reasons why I said take a long time. The next point, more. I don't know too much about car. They are evolving. So whatever we talk about will be in commercial vehicles. Of course, one night that commercial vehicles are probably going to be the easiest in India to start. The reason is India is not a very cash-rich country. So people want maximum money sense. And vehicle, if you take a auto, it travels about 150 per day. If you take a taxi, he probably does about 200 kilometers. If you take a bus, city bus, he does about 200 250 kilometers. But if you take a fossil bus, he might even be 350, 400 kilometers a day. And if you take one again, 300, 400, 500 kilometers a day. Unfortunately, if you take a two-wheeler, he does an average of about 50 kilometers a day. Same thing for the time. So electric vehicles, they make money sense when you run more number of kilometers. So commercial vehicles are going to be easier. And anyway, even if you want to talk about passenger cars and two-wheelers, I can probably give you, but really I don't know enough to take a full webinar session on that. Next, so please remember, all that be essentially commercial vehicles, electrification. The next point, as I said, COVID is definite to change direction for two major reasons. One, the first one is the governments all over the world are going to have only so much of cash left after this disaster. So, yeah, Priya, you can go to the point. So what happens is, because the government has only so much, it's going to focus more on the economy and beefing up the economy, contribute. All governments will be spending their energy and money in reviving their economies and not really in protecting the environment. They'll once again come back to the environment journey after a couple of years when the economy picks up and government can afford to go back to environment. Of course, there is a lot of philosophy here. I'm sure this by itself is a debate which people can spend hours and hours. But for now, overall industry expectation is that the governments will first divert all their funding, whatever they can get, and they have very little of that now. They will give the funding to economic activity. Priya, can you go to the next points, please? 1, 2. So fossil fuel price, as I said, it's come down already. You guys must have noticed. Of course, because the cost of fossil fuel vehicle is improved and the cost is reduced. So two reasons which I have mentioned here: fossil fuel price fall as well as money being spent on the economy by the government. These 2 points are going to really of electrification. We will see at least a 2-year phase lag where electrification will not take off that majorly. Next point, please. The next point for everyone to remember is that the market, supply chain, cost, all these are constant e-mobility space. Leyland has been in this business since October 16. That's when we launched our first electric bus. The last 4 years, 3.5 years, seen costs, technology options, the market behavior, new markets being suppliers disappearing. So a lot of changes are constantly happening. The reason is simple. This is a greenfield area. So people of what the correct configuration and what the correct policies will. So all these result in a flux. There is a fair amount of change and change. So our entire business is modeled around this change, and we are prepared for this change. And this is how it's going to be. So if you're getting into this industry, you don't expect very mature and stable right from day one. Our expectation is, at least for the next 5 to 7 years, there will be a lot of flux on all fronts: technology, suppliers, markets, the cost structures. We expect all of them to be they're very, very dynamic and volatile. Next point. Surprisingly, academia is yet to catch up. Most of the research and most of the new developments are being done by industry. Last 1.5 years, we've seen some level of academic activity. The point is fundamental. But this is changing. More and more academic institutions are getting into fundamental product development. And the fundamental research is usually left to the academic institutions or labs. So here you see the academia going a little slow. Next point. And that e-mobility is not just the vehicle system. Charging the vehicle is a huge area by itself. Managing the grid to suit this charging pattern of different customers with different vehicles using for different applications, the entire grid is slowly going to have to be automatic and digital. So if you look at people like ABB, they have a digital twin of the grid, and they are always modeling to manage the grid. So this is an important aspect. The next one is the life cycle. In terms of do you manage, which is different from the battery life. At the end of the vehicle life, what do you do with the batteries? What do you do with the motors? So there is quite a lot of life cycle management. It's not just about designing the vehicle. And then lastly, of course, all of us know about connected vehicles. In the electric vehicle ecosystem, connected vehicles are even more rampant. It's basically money. If you have a connected vehicle which is electric, you're able to and save a lot of money, and therefore it makes sense to have connected. Of course, not really true fully for two-wheelers because they're very low-cost products, but cars, trucks, buses, these are all connected, completely connected. We'll talk about this at the end, but remember that India has unique requirements. If we have time, I'll explain what the unique requirements are right at the end of the session. But remember that India has unique requirements, and we need to solve the problems for India. If we are going to be looking for jobs in India, we will need to necessarily look at how to solve the problems for India. The grid is a different animal in India. The kind of environment and the ambient conditions are different. Application, consumer behavior, everything is different. So if I bus from our UK company, Optare, running here in India, we have electric. It is here, I'll probably see the bus collapse in less than 2 or 3 years. So we have to necessarily look at context. It's an important part. Context. I'm going to talk to you about product and personal and public safety, a quick run through just for you to understand what are the areas. This itself is turning out to be a career for people. In fact, we have a full safety officer in Ashok Leyland. Next slide, please. So for e-mobility, we have a full-time, high designated, high safety officer. So it's not a small topic as of today. Going through some details, but first in product safety, first and foremost, you need an emergency cutoff. Maybe two-wheelers and to some extent cars, they are okay because they are lower voltage system, but even cars are moving to about 300, 350 volts DC. Above, I think above 80 volts or 60 volts DC is considered dangerous. Now, cars will be running at 300, 350 volts DC, and buses already run at 650 to 700 volts DC. So these are really high voltage systems inside that bus. So you need where you can cut off the energy. That's emergency cutoff. You have special attention for high voltage wiring and how the aggregates are designed, how they are connected, how the wire, heavy duty orange wires go. These are all important. Of course, battery fires, you must have heard of it. You'll be surprised to know that even though you read a lot about Tesla cars and some China buses and cars catching fire, electric vehicles catching fire, it's nothing. It's just that it catches more media attention. Right now, we are all used to gasoline fires, so it doesn't get reported much. But batting the fire and suppress fire automatically on the battery is important. And you should understand that battery fires are different from gasoline fires. We will talk about it later in public safety. And it's also important to get your layouts, how the wires get connected to the aggregates. So the termination, the terminals, the connectors, these are very important parts for safety. In terms of personal safety, there's quite a lot of equipment that we have to give the people. One set of people are the guys who are assembling these vehicles in our factories. Second set of guys are guys who are maintaining these vehicles on the road, the work. And third, it is the driver who actually can negligence. So it's important to have person implemented through training. And finally, we go to public safety. Like the fire station and police and emergency ward. And suddenly we realized that nobody had trained the firemen and the police and the emergency ward to react to a electric vehicle fire. And then within the next 1 week, 10 days, all of us panicked and we worked with them and we implemented a thorough training. This has not yet become routine. It's not become policy. It's not become regular for everyone. So this is an important part, the first responder trainings can save lives and also ensure that people just don't go running to a bus which is already undergoing an accident. Second is public awareness. People have to be taught when there is an incident with an electric vehicle. And finally, the vehicle designer, vehicle maker, vehicle user, and vehicle maintainer. There is a lot of responsibility for buses, especially because the passengers are completely at your mercy. So Ashok has very, very elaborate protocols, and it tends to be a work culture. So it is an important concern. Next slide, please. So if you look at vehicle safety, well, these two pictures are classic examples. The first one, let's have the battery in the back of that bus, the picture on top, and this car has gone and rammed into that battery. Obviously, there's going to be a high chance that the battery might catch fire. Now, there are various regulations and various standards which have been evolved. So, based on that, the battery fire chances are almost entirely eliminated. But say and improving instantly as the knowledge. More and more new solutions which will eliminate this risk completely. So it's good to have vehicle safety. Your vehicle. The other one is here, typical bus wading through about 300, 400 millimeters of water and ionized is reaching high voltage systems. So you need to design your bus so that these do not result in safety incidents or failure modes. Next slide, please. So, as I said, even when there's an emergency, you should have these stop buttons all over the place, along with electronic controls. Like high system maintaining the bus or producing. So if you very elaborate and specialized tools with high insulation handles, a lot of training, more training. So we have to train these people to work accordingly. And the way an electric vehicle assembly line is operated is very vehicle assembly line is handled. Gas is built. Remember, there's no energy inside it. You fill gas, you have to fill petrol. But in the electric vehicle, the battery comes. So the minute that comes on bus and you pick it, you're lot of predictions, lot of training. This is just to give you an idea. And there are quite a few warning symbols which we guys use. So coming standard now, the minute you thing, you know that you're going to be opening into a high voltage area. So these are all new. So, uh, information. Just guess what is going to be presented. Let's see how it pans out. Um, between an and a hybrid, right? Next one. Thank you. Being supplied to an engine, and the engine generates mechanical movement, and use transmission, you rotate. Now, this is regular IC engine, right? This is something which most of us are using all the time. Now, next is the next slide, please. You will see the hybrid vehicles. Now, on the right, you have the battery electric vehicle. It's very similar to the IC engine. You have a battery instead of a fuel tank. It sends energy to the motor generator, and the motor or generator transmission which drives the wheels. So there is really not much difference. Now, hybrid is a fairly complex system with its own advantages and disadvantages. And the has both the energy suppliers, the fuel tank as well as the battery, and each supplies to its own machine, either the engine or the motor, and they hybrids, you have series hybrids, quite a lot of options. So it's definitely got its own space, and it's not very wise to look away from hybrid, saying no, I will do only electric. It's not the city buses. Yes, going to electric makes a lot of sense. You should just go straight to electric instead of hybrids. But if you look at cars, especially small distance cars, personal cars, which don't do more than 50, 60 kilometers, hybrids have utility than a full today. It's changing. So as long as it makes sense, we should retain hybrid options. Slide, please. Now we see how it actually evolves, right? Um, so what happens is the engine is idling for a automatically um, the engine stops at signals, let's say, and when you press the accelerator, it will kick start again. So that's a micro, very simple device. And the next level you see is it brings in regenerative braking. So in that, it's called a medium hybrid, where as you slow down, you try to not brake, but actually use the motor as a generator, and you reduce the speed of the vehicle. This is called a mild hybrid. And the next, you have where, in addition to these two, there is also an electric energy provider in the form of a battery, which where it drives the motor, and the motor assists the engine in transmitting power to the transmission. So this is called a medium hybrid. And the next one, finally, you have what is called a strong hybrid, where the primary drive is actually electric, and the diesel or fossil fuel drive is used to uh, mm, supplement the performance of the EV drive. The next one, it's called a plug-in hybrid. All of you know about this, I guess. Here, in fact, for a given number of kilometers, it can run as a full electric vehicle. It will not even start the engine. So this is a plug-in hybrid. And finally, of course, you have the full electric vehicle. So it's so you have various levels of hybridization, and there are different advantages and disadvantages for each of these. And remember, finally, it will all come down to the money calculations. Does it make sense money wise? And can I use it for the application that I need to? Next slide, please. So this is just a bus which we did. This is the only India's only ultra capacitor based hybrid bus. We guys used ultra capacitors instead of batteries, and it was a pretty good product. I think we had about 26% improvement in energy efficiency. This is just for your information and reference. Next slide, please. Now we talk about electric automotive mobility. You've got these two-wheelers, you've got the cars, you've got the buses, got trucks on the right. So you've got all these can be electrified. There's no problem, right? And the tech is available. Does it make money sense? Does it make operational sense is the question. It always makes noise sense. So it is a very quiet vehicle. So all these are the different types. But to me, in India, um, can you click once? I think the auto is the first to arrive financially. You forget about this COVID phase, but before the gasoline prices fell, an electric auto was cheaper to own and run over a period of 5 years as compared to a petrol or a diesel auto. Now, this was the first vehicle which made money sense in India. And if you see, suddenly electric auto sales went up. No other electric vehicle went up so much. But electric autos, which did anything between 150 to 160 kilometers per day, they immediately started selling very well, because not the environment, not the government rules, nothing. It just made money sense. So people started using it instead of buying fossil fuel vehicles. So this is something to keep in mind. And this is the first segment where we have commercial success for electrification. Next slide, please. Here you see two Ashok Leyland vehicles. They might look the same to you, but the technology inside is different. In the first one, what we do is we swap the battery. So it's a small battery. It's only about 65 kilowatt hours. Every 31 kilometers, the bus comes back. So you have a route which is about 31 kilometers. So it will run for 31 kilometers, come back, you'll swap the battery, and it will go for another 31. So like this, these buses do close to 280, 290 kilometers per day. They just keep changing battery and they keep running. So it doesn't wait for get charged. Now, the swap takes only about 2.43 minutes maximum. So the bus duty cycle, the schedule, nothing gets affected. It's running quite successfully in Ahmedabad, but it has limited application. So if the route length is, let's say, 55 kilometers, then I don't have a swap solution, right? But the point is this better technology or is that better technology? Next one is a fast charging bus, where we put a lot of energy into the bus right in the morning, over the night, over the night parking in the depot. And morning when it leaves, it's got a fully charged bank of batteries. And it comes back after 200, 220 kilometers. It comes back in the night. Now, which is better? I don't think it's right, because look at the first bus. It could do only 30 kilometers per trip, but it is doing 290 kilometers per day. Look at the second guy. He doesn't come back, but he does only about 200, 220 kilometers total. So it's incorrect to interpret this as which is better. The correct way to look at these options is to see which makes better money sense and which is operationally feasible. So it is not about one technology over the other. And especially in commercial vehicles, we are not here to decide for the customer what is good for him. We give him the solution which is least expensive for him. Because commercial vehicles, there are only two rules. One, your customer has to make money. The second rule, your customer has to continuously make money. There is no other rule in commercial vehicles. So as long as you enable this, you are able to have a successful sale. So you don't talk about this technology is better than that, etc. You develop different technologies and offer it to the customer based on his needs. You'll be very happy to know that there are only two companies globally which offer such solutions. One is our own Ashok Leyland in India, and the other one is MAN in Europe. So these are the only two companies which actually do solution design for customers instead of selling standard products. But most European companies are headed this way. This is the right way to take care of customer requirements. Next slide, please. So eBus architecture, give me a minute, please. Let me time myself. So eBus architecture, next slide. The taxonomy of the vehicle, you've got three areas. One is charging infrastructure, energy storage, and propulsion. Right? And the first part, in charging infrastructure, there are various types, as you can see. And under energy storage, you will see that you have batteries and fuel cells. Once again, a lot of options. Under batteries, there are very many options which have come up, and they continue to come up with new options. And finally, in propulsion, you have both electric and hybrid, as I explained, and you also have range extended electric vehicles. So this is a large domain area. The topic by itself will probably take about 3 to 5 hours. So this is a very evolving and constantly changing field. You'll do well to go through the theory after you decide which area you want to work on. Otherwise, you will be wasting a lot of time. Next slide. This picture gives you a rough idea of how a bus is handled. So you've got a body control unit, which takes care of the bus body. You have a vehicle controller and an inverter, an auxiliary inverter to drive all the smaller aggregates. You have the HVAC or the air conditioner. You have an electric steering. You have an electric compressor. And then you have what is called the traction inverter, which is always coupled to the traction motor. The inverter drives the motor. And that's a very key part of the technology. And you have your famous lithium-ion batteries. with NMC chemistry or whatever. But we guys in Ashok Leyland, currently we are using NMC chemistry. And I stress on the word currently because we believe, as always, that you do not stick to one technology if another option is better for customers. Even in charging, you have slow charging with alternating current, and you have DC fast charging, and you have flash charging. I'll show you the picture in more detail later. But in flash charging, you can actually charge very, very fast. And in case you have a fuel cell, you can put it in the bus, and the fuel cell will keep supplying energy to the batteries and keep charging them. It will keep consuming hydrogen and it will charge the batteries. But it's right now a theoretical exercise and a technology exercise. It doesn't make operational and money sense yet. Next slide. We can skip this one. This is basically a slide which shows you AC charging and DC charging. So vehicle charging, the next slide. First, you see what are called trolley buses, overhead lines. This is Eastern Europe, Russia, Hungary, etc. It's quite popular where they have those lines running up there, and this bus runs like a tram. It will keep touching that wire and running all over the place, but the infrastructure costs are quite high. The next, what you see below pantographs, is what is for flash charging, where you can have even 300, 400, 500 kilowatt chargers. So you can charge very, very fast and very rapidly. But there is a price to pay for this because the battery, if you charge it very fast, battery loses life. So do you want to charge fast or do you want a long life is the question. And there are people who are working on technologies which will deliver both. The next one is a simple plug-in charger on the top right corner, where you charge for a few hours and then get going. This is the most common usage right now. And one interesting area which is evolving in the bottom right corner is induction charging. It is still in pilot and technology demonstration phase, but it's a fairly robust technology where the bus comes and it gets charged from the bottom, and here you can once again charge very fast. But there is a fairly high demand on infrastructure for the first and the last one, that is the trolley bus and the induction charger. Next, what you guys wanted to see. So this is the domain and carriers in EV. Next slide, please. So if you see this, I'm showing the same taxonomy again, but the point is, click once, please. In the first area, you have power electronics, power distribution, connected vehicles, mobility planning, energy distribution, electromagnetism, EMI and EMC, and good old electrical engineering fields which are heavily influenced charging infrastructure, and these fields are required to deliver part of e-mobility. Whatever is highlighted in yellow, it tells you that this is a very evolving area where there is constant change and there is constant upgradation of technology. Next is the battery area, where batteries, the biggest research that's going on right now. So the battery cell is evolving day by day. A lot of research going on. The next one is thermal management, where you manage the cells which are put inside a pack. Microelectronics, power electronics, once again, material sciences and metallurgy, huge opportunities here. And electrical and thermal efficiency. These are all parts of the technical courses which will have an impact on the battery part of the business. And finally, when you go to the propulsion side, you have very similar areas, except that you will be having electrical machines, motors and stuff like that. Control algorithms, which are very important, and vehicle engineering. So all areas where people need to specialize and people need to develop competence, right? Finally, top of all this, can you click once, please? You have a major area evolving, mobility and e-mobility. Now, this is absolutely great. Nobody globally who's developed a comprehensive mobility system or comprehensive e-mobility system. So it's wide open and it is just starting, and very exciting area because it calls for a lot of public policy, calls for vehicle technology, calls for city planning. So this is a huge area of opportunity which is evolving. One nice thing is it is evolving along with e-mobility. So that's a good sign for everyone. So finally, how e-mobility journey? Uh, please. So if you see, there are various areas which are evolving. Vehicle to grid technology, where the vehicle will start supplying energy back to the grid when it is not being used. Autonomous driving, all of you have heard of it. There are levels of autonomous driving. So what will not work for India, what will work for India is a matter of now, but honestly, there are level 2 and 3 which can be implemented in a lot of places in India. You have connected vehicles, which are constantly evolving now. Shared mobility. With electrification, shared mobility is more attractive because you really have low operating costs and high upside. And the IoT and the cybersecurity part as well. I think these are topics which all of you are aware of, and you will need to continue staying aware of. So finally, staying with mobility, e-mobility. Next slide. Remember that ICE vehicles are going to be around and dominant for a long time. So don't assume that they are dying. Every area in EV has potential, every single area. The next point. And the next is take your time, identify what you're passionate about, don't be in a hurry, and then start preparing in that field. And best is to constantly keep reading about the related stuff as well, but focus on the area that you have chosen to make your career in, and keep track of the related areas in the main EV and e-mobility space. And it's easy to actually take a non-automotive fundamental course. You must have noticed that power electronics has got very little to do with automotive. So you need to do non-automotive courses to gain competence for electric vehicles. And then you move to the auto job, learn in that by working in the company. Right now, there are no major uh, uh, which offer that. Reading choice because things are changing constantly. So you can't attend one course and build subject because you got a good grade. You reading and you have to keep up to date. And then get into various fora, various ecosystems where you will see people, you'll keep interacting with people who are in this area. It's going to be a case, don't stay, you will necessarily become irrelevant. And as I said, avoid choosing a specific philosophy or strategy in electric vehicle. It is evolving too much now to have a very open mind and technology instead of jumping to conclusions about countries or their concepts, etc. And go for the non-core core areas if they interest you. Don't go for the vehicle, go for charging, go for mobility, go for energy management. There are quite a few areas which are flanking. This is not true in the automotive world, IC engines automotive world, but here you have a lot of flanking areas which are related to the EV with equally great amount of potential and future. And it's a long way off. If you have 20-30 years left in your career, you can do very well without EV technology. It's not something you have to know, but it is a upcoming area. So your stakes are higher, but your rewards are going to be higher as well. And I think most important, remember to enjoy what you do. You know, success comes anyway. You need to work and enjoy what you do. That's most important. I think we've kind of come to the Yeah, how is the session?
So you can take 5 more minutes. Then we'll address some questions that some people have posted.
Hi, yeah.
Till 12,
Questions.
1 hour session. Okay, sir. We have a question coming from Abhilash. He's asking if an EV gets caught in an intrinsically originated fire, do we have any AI-based fire extinguishing system on board?
I can't hear you very well.
Sir? Yeah. So there's a question from Abhilash. Can you hear me?
Mm-hmm.
He's asking if an EV gets caught in an intrinsically originated fire, do we have any AI-based fire extinguishing system on board?
It's not AI based, but it is sensor based.
Okay.
They are called suppression systems, so they are used quite elaborately.
There's another question from Vishnu Dattan. Um, with the increase in the number of electric vehicles, will they cause a power crisis in the country like ours?
Well, that's an interesting math you can do. You can, that's a nice way of learning. You will, if you do the math, you will see that it is not a very significant amount of energy as of today. So you can sit down, look at the number of two-wheelers, multiply it by the amount of energy they will get. Same thing with cars, etc. Honestly, if you stack it up, it's not going to be more than 6 or 8%. Point is, this percent comes at a specific time of the day. So at that time, this you won't run out of energy. You have an imbalance. You will need to come up with strategies where you will make it attractive to charge when the grid is low. In EVs, you have a lot of flanking carriers, and grid management is one of them.
Okay. So then there are some graduates from electrical and mechanical engineering who would like to know if about the extra courses that they'll have to do in order to get into companies like Ashok Leyland, like engineering graduates from mechanical engineering as well as electrical engineering. Uh, if they have to do any additional courses, what are the additional courses they'll have to look into
Yeah,
in order to get into industries like?
it's sad because there are courses which you can do, but there are no such courses. What do is hire the same whenever we get regular graduate engineer trainees, either electric or mechanical, and we train them. But that's very unfortunate because it's a waste of time and waste of money. And it'll be good to have the academic courses set in place. I think some of the colleges have started, but there is nothing which is really very so. As of now, there's nothing for you to attend. You do your BTech, MTech, you do your subject well. That's all that is required as of today.
In terms of these courses, there is another question. Even though it was mentioned that the academy has yet to flourish in research and courses, does Ashok Leyland provide any courses related to EV or e-mobility? And what are the job opportunities in e-mobility sector in India? Hello? Hello?
Priya,
Hello.
Yeah, hello.
Yeah, exited so that I can. Let's see. I didn't hear
Okay.
anything you said so
Yeah.
far.
Okay, I'll repeat the question, sir. Another question is asked. Even though it was mentioned that the academy is yet to flourish in research and courses, does Ashok Leyland provide any courses related to electric vehicles or e-mobility? And what are the job opportunities in e-mobility sector in India?
See, right now is a bad time, especially for commercial vehicle guys. We've had about 1.5 years of uh, lousy market. Now we have BS4 to BS6 transition. This COVID has happened. So you really don't want to look at something right now. But essentially, are uh, hiring permanently with electrical engineers who have done well in their subjects. And, confident of applying the fundamentals. These are the people we have typically been hiring. The core automotive, the mechanical and the automotive engineering, we already have in-house competence. We have basically groomed people various roles in power electronics and motor engineering and battery engineering, in overall vehicle and system integration, control systems. So we've had to develop people in-house. So there are opportunities. Right now we have limited hiring. There is not many companies, but everyone will be looking for people like this as and when electric vehicles take off again.
Okay. There is a question from Vaibhav Mangal. Ashok Leyland Hybus comprises of which hybrid category? Also, how much energy savings we are achieving by regenerative braking system? That's a question Vaibhav has asked.
Yeah, and amount of energy that you get from regen is dependent on the actual cycle. So if you have a certain drive cycle which allows you to, then you can reach 18%. So it's quite a big amount. And if you look at the hybrid bus, because we could regenerate store back, it had about 26% improvement.
Yeah. Jeevesh has asked, how does smart grids cater to setting up of EV infrastructure?
They do. And India Smart Grid Forum is actively engaged with a lot of us as well as the other agencies. Smart grid is one area which is going to be a massive career opportunity because it's something which has not just for electric vehicles but across various usages. So smart grids is definitely something which is going to make paradigm changes in the market.
There's one more question. Aneet Mishra has asked, electric mobility consumes power from thermal plant. So can there be a scenario where we sell renewable energy with electric vehicles?
Yes, in fact, this is one of the high philosophy debates, mainly in Europe. Um, they are very clear that there's no point in having electric mobility if you're going to generate the power with thermal plants and other stuff. Um, there are different ways of looking at it. My approach is you're in India and you have lousy city air. So I'm addressing tailpipe emission. I'm not addressing overall country emission. I'm very clear. And I go ahead with electrification for the sake of tailpipe emission in cities. Now, the amount of energy that I have spent, it's marginally more efficient to run it on electric vehicle compared to a diesel vehicle. Math can work any which way in terms of environmental efficiency. So with renewables, with battery buffering is the way to go. And if you look at people like Quebec, who have about 97% hydroelectric power, and if you look at most of the European countries, they are talking about as rapid of implementation of renewables is possible. Just that the guys don't have enough sunlight there, and they have to rely on wind, and that's not also a very high amount. So it's going to be difficult for the people in the temperate zone. But for India, especially with the aggressive targets that this government has set for renewables, it's probably going to really make a lot of overall environment sense. But using energy, renewable energy for electric vehicle is very much the agenda.
There's a question. Why aren't trams used much in Indian cities?
A huge number of reasons, but most of it is, you can boil it down to three culprits. One is the public lack discipline. Second is the police who do not enforce. And third are the officials who really don't go about enabling. A huge topic. But the point is, it's a very, very efficient and very good mode of transport. And it's unfortunate that we have lost it.
Okay, one last question, sir. What's the role of AI going to play in battery management system?
See, there is no place where AI cannot play a role. It's a fundamental tool. It's you're building intelligence into the system. So in terms of active management of cell voltage levels or active management of delivery of self-diagnosis, life extension of the battery pack by balancing cell usage, there are going to be huge opportunities for AI, not just in battery management systems, but electric vehicle management as well. So it's a no-brainer. Any place you want to take AI, unless it has zero electronics, it's going to.
Yes, sir. That's it. That's it from the question session. Hello.
Hello.
Hello, sir. Can you hear me?
Are we done?
Yeah, we are done with the questions, sir.
Okay. So all the best to everyone, and have a good electric career and stay healthy.
Yeah. Thanks a lot for the session, sir.
Sure.
Since electric vehicle is the most trending and the evolving technology right now, your expertise in the field has actually given us a more informative session, actually. So thanks a lot from all the sapiens out here, and
Sure.
thank you all the attendees for attending the session. Thank you and have a good day.